You have a question. It could be about anything, from the name of a movie to the capital of Kyrgyzstan. You type it into a search bar, hit enter, and in less than a blink of an eye, you have an answer. It feels like magic. But how is it possible? How can one single program sift through the entire internet and find exactly what you need in half a second? To understand the answer, you first have to understand the problem. The internet is not a neat, organized library. It's a chaotic, ever-growing universe of information with billions upon billions of pages. Think of it like a library the size of a planet with no central catalog. Books are added every millisecond. Pages are torn out, and entire new wings are built without anyone in charge. If you were told to find a single sentence inside this planetary library, it would be an impossible task. It might take you centuries, or you might never find it at all. This is the incredible challenge that search engines face every moment of every day. How do they bring order to this unimaginable chaos and deliver answers instantly? The first thing to know is what search engines do not do. When you type in a search, they are not sending out a lightning-fast robot to read the entire internet in that moment. That would be physically impossible. The speed of light itself isn't fast enough to travel across all the servers that make up the web and report back in under a second. So the secret isn't about searching faster. The secret is that the hard work was already done long before you even thought of your question. Search engines work in three main steps. The first step is called crawling. It's how they explore the vastness of the internet. They use special automated programs called crawlers or spiders. You can imagine these as tiny digital explorers. Read the page and make a list of every single link on it. Then they follow each of those links to new pages. On each new page, they do the same thing. Read it and find all the links to follow next. They jump from link to link, creating a constantly expanding map of the internet. They discover new websites, new articles, and new pictures as they go. This process never stops. Billions of spiders are crawling the web right now, 24 hours a day, 7 days a week, constantly updating their map of what's out there. They are charting the territory, finding new paths, and noting when old pages disappear or change. This relentless exploration is what allows a search engine to know about a brand new video or news story just minutes after it's published. A spider has likely already visited that page, recorded its content, and sent the information back to its home base. But just knowing which pages exist is not enough. This brings us to the second and arguably most important step: indexing. All the information gathered by the crawling spiders is sent back to the search engine servers to be organized. This process is called indexing. The index is the real masterpiece of a search engine. It's like the ultimate index at the back of a giant encyclopedia covering the entire internet. For every word you can think of, the index stores a list of every single web page where that word appears. Think about the word robot. The index has a massive list containing every page about robots, from engineering articles to movie reviews to toy stores. It doesn't just store the word, it stores where on the page the word appears. Is it in the title? Is it in a heading? This context is crucial. This index is unbelievably huge. It takes up a colossal amount of computer storage, housed in massive data centers all over the world. Building and maintaining this index is one of the biggest engineering challenges in modern computing. It's a full-time job for an army of computers. So when you search, you are not actually searching the live internet. You are searching this pre-built, super organized index. This is why it's so fast. Searching a well-organized index is millions of times faster than searching the messy, chaotic web. It's the difference between flipping to a word in a book's index versus reading the entire book from cover to cover to find it. But this leads to one final problem. A search for robot might point to millions of pages, How does the engine know which ones to show you first? This is the third and final step. Ranking. Ranking is the secret sauce, the complex algorithm that sorts the results from most useful to least useful. Search engines use hundreds of different factors to rank pages. One of the most important is relevance. Does the page contain the keywords you searched for? They also look at authority. A well-known museum or university website is generally considered more trustworthy than a brand new, unknown blog. One way they measure authority is by looking at links. If many other important websites link to a particular page, the search engine sees that as a vote of confidence. It tells the algorithm that other people on the web find this page valuable and trustworthy. Another ranking factor is freshness. For a search about a recent news event, you want the latest information, not an article from 10 years ago. Your location also matters. If you search for pizza delivery, the engine uses your location to show you restaurants that are actually near you. All of these signals, hundreds of them, are fed into the ranking algorithm. The algorithm weighs them all and calculates a score for every page in the index. The pages with the highest scores are the ones that appear at the top of your search results. This algorithm is constantly being tweaked and improved by thousands of engineers to make the results more and more helpful. It's a system designed to understand not just what you typed, but what you actually meant to find. So let's put it all together. Crawlers explore the web. The information is organized into a massive index, and an algorithm ranks the results for you. The big insight here is profound. The magic of a search engine is not about incredible speed in the moment, but about incredible preparation ahead of time. It has already done the work for every possible search you could imagine. It has read the books, written the index, and organized the library. Your search is simply the act of asking the super intelligent librarian to look up your topic in their perfectly crafted catalog. The answer feels instant because the system was designed to anticipate your question before you even asked it. This elegant solution, combining constant exploration with massive organization, is how computer science tames the wild frontier of the internet. It's a powerful example of how a complex problem can be solved, not with brute force, but with a clever, systematic approach. So the next time you search for something, remember the invisible army of spiders and the colossal index that make it possible to find anything, anywhere, in an instant.